So hi, as they said, I'm Dave McAllister. I'm an open source technologist for a little company you may have heard called NGINX. We are owned by F5, but we don't tend to be NGINX everything else. And I want to talk about NGINX Unit, which is a special application server space for this. I also would like to introduce up in the corner, there was NGINX. NGINX is NGINX with the N silent. I'm going to talk about WebAssembly. WebAssembly is one of the new technologies that if you haven't looked at, you need to look at now. It is a binary instruction set for stacked-based virtual machines that basically allows you to run your application once it is compiled to this byte code anywhere you want to. A stacked machine has a set of instruction types, the instructions, and the program. WebAssembly can be cross-compiled from almost any language that there is, and it was built originally for client models inside of a browser. So it's been around since about 2014, but it's now moving into what we call the server-side environment, where we now be able to write anything we want to, and almost any language we want to, as well as this thing called WebAssembly text format. So once you've got any of those languages, you can now run your applications without changing them on any environment. You can also merge the things together so that you can build inside of your separate languages. Lots of companies are using this. I got most interested to one of my former employers when they took Photoshop native and ran it in WebAssembly to your client at 95% of the native speed without changing their code. That is what told me that WebAssembly is here to stay. So what happens with web applications? Rather than grabbing the whole application, we now split these things into front end and back end. It allows us to have choices for our languages. And it allows us to build separately so we can build special functionality into either side. It does have some separation concerns. Once we separate it, how do we talk back and forth across that? So what happens is that you end up with a set of code that calls off to something, usually HTTP2, HTTP3, but it's hard to represent on a slide. It then generates its information and comes back, 200 message OK, and it gave you the answer that you've sent for. So this is the client front-end, back-end loop. What happens is the server does some interesting pieces. And so it has to pull the input together. It has to build the result that's there. It has to tell it that the correct number is coming back, and then it's got to send the result back, and then all you're doing is running the application. Anytime you make this change, you're going to have a different effect on that side. WebAssembly does that with a byte stream. Therefore, it's a lot smaller, a lot faster startup, and it basically blasts through, and that's one of its advantages. It is blindingly fast on start. It is also much smaller. It is a compiled binary. So it's much smaller than trying to ship around a JavaScript or a Java environment. So building that WebAssembly web app, you have to worry about all these different pieces. Your client talks to a network layer all the way down to a code execution layer. And each one of these layers has its own piece of stuff that you have to worry about when you're building a web application. For instance, you've got to worry about security aspects in here. When we look at this, what we want to do is separate the code execution from the web environment. And that web environment still has to be there, but we want this sort of magic to happen. Code is separate from the web. Applications are separate from the web. We have to deliver this with everything. So why do we worry about that? So this project called Unit is this application server for web applications that's multi-language. And what it does is inside of here is that all of the HTTP and routing stuff is over a shared memory model. Every one of these things is fully sandboxed. The applications don't cross streams. They don't share the memory. When we do the same thing for the Wasm time, which is one of the runtimes for the server environment, we deal with this linear memory model. So the Wasm time application talks to its HTTP context. HTTP context goes out to the router. The Unit product has the router, reverse proxy, all those pieces. Linear memory is pretty straightforward. It basically says, ask for this amount of memory, get a pointer back. Put the stuff you want in memory, and then return the memory to the memory page with its data length, and then you can free the memory. This is a bit of a headache right now, because once it's there, it's hard to change. So Unit allows me to do all those things that I've just talked about, the routing functionality, the reverse proxy functionality. It provides built-in TLS with API configurations for, there's roughly 8 languages here. What we've done is added WebAssembly to this product. So you can now have an application, a web application server that does it all. And so the server now changes. The same client model, the same return model here, but our model that is all here no longer has to worry about anything in that networking space, that web environment. That's all handled for you dynamically. So as it changes, you can change that. And so over here, we're building this functionality. We're building the pieces that tell us what we wanted to do. In this case, I changed languages on you for that. And then the response goes out. This can be changed literally on the fly. When you change it, it comes back. So the developer experience is really important here. WebAssembly gives us the ability to use the things we want to. Only works if we do have universal portability. And so we need to separate HTTP from the Wasm runtimes so that they can be there at all the times. Once we do that, we believe that innovation will follow along. And the product is on GitHub. It's open source under Apache. We'd love to have you involved, and we'd love to be able to have you give us your insights on where WebAssembly is going as well. And with that, thank you.